this horizontal member. Instead of that, with this vertical wall, two connections are there, and at two hinge locations or the two end of supports, rather end of members at these pin joints, two vertical downward force of not given any numerical value. With this symbol capital P, it is indicated. This is the geometry. Same distance, small a, inclination is 30 degree. So from this isosceles triangle, you can find this angle is also 30 degree. And you have been asked to find out the forces in this member 1, 2, and 3. Okay. Now for that, normally what we do, we assign some joint names. Okay. Of course, the member has been numbered in this way. It has been assigned with this number 1, 2, and 3. That means the force in the member CE, force in the member CD, and force in the member BD. Now, what you do, instead of starting from this joint A, find the value of SAB and SAC, then come here, you determine S3, that is SBD, then you come to this joint C. This is already known. It will be from sigma Fy is equal to 0, it will be minus P. So all such things are there. Actually, it will be plus P. P is acting downward, so SBC will be acting upward. So solving 1, 2, 3 joints, we can find the value of S1, S2, and S3. Now, another method is there. When instead of considering the equilibrium of individual joints, we consider that the whole truss is cut by a particular imaginary plane, and we consider the equilibrium of either the right hand side with reference to the section, or on the left hand side the portion of the truss, and along with the applied forces, if there is any support, including that support reaction already calculated, we indicate the replacement of these members by their forces. So in the member 1, this is the force S1, in the member 2 it is S2, and it is S3. Nomenclature is like that. And imaginarily, if this part we are not considering physically, that truss, but geometrically you can extend these lines, and here is that point, the actual location of point D, or the joint D. Here is such location indicating the joint E. Of course, it is not there. Now, next step was to find S1, S2, S3. This is a non-concurrent coplanar force system, and you can solve for three unknowns. So for these three unknowns, what do you do? Either you generate three independent equations, one from sigma fx, one from sigma fy is equal to 0, other from some moment equilibrium equation, or independently, if you can identify three different locations to be considered as moment center, and you are conveniently selecting those moment centers so that maximum number of unknowns are eliminated directly. So if we consider this point D as moment center, so in that equation sigma md is equal to 0, we are automatically removing this item S2 and S3. So only unknown left is S1. So S1 multiplied by this perpendicular distance, of course, that geometry, trigonometry, everything you must be very much conversant. So perpendicular distance is twice A multiplied by sine 30, that multiplied by S1, that is anticlockwise. There should be some kind sign convention, and you solve it. Yes.
सर पूरे ट्रांस सिस्टम को दो पार्ट करेंगे, जब मतलब जिस पार्ट का हमें कैलकुलेशन करना है उसी पार्ट के फोर्सेस को इंक्लूड करना है ना मोमेंट के इक्वेशन में, दूसरे पार्ट का नहीं आएगा फोर्सेस, या फिर दोनों के आएंगे?
Exactly. But if you are asked to find out this member CD, this member S3, and this member AC, so if BD, CD, and AC you are asked to find out, then you cannot pass a single section normally by this single plane cutting section. Maximum what you can do, you can pass a section like this. So when you pass a section like this, just hold a minute. Suppose this is section 2.2. So can you find this brown line?
Yes, sir.
Yes, sir.
So
Yes, sir.
in that case, you will find this is included S3. Here is the force in the member BC, and here in the force in the member AC. You have been asked to find out this one and this one and this one. So a single section cannot give you the solution for this member CD, that is the S2. So that is the problem. So you have to be rather having good experience through practice, that you must select a section so that it cuts the members conveniently and giving you maximum number of requirement being cut by that plane. Okay, so a single one or two problem will not give you all such information. For this particular case, a simple situation when CE, CD and BC have been asked to find out, then a single section 1-1 will help you, but not necessarily the system will be like that. Now, if by any chance you are asked to find out the forces in the members AC, BC and BD, in that case, this section will be sufficient, a single section. And there you need to find, if you consider the right hand side portion for equilibrium, so indicate this force there, indicate this member force and indicate this member force. So a single section will help you. Now, if you select B as moment center, so sigma MB, sigma MB equal to 0 will give you the solution for this one. Next, if you select A as moment center, so sigma MA is equal to 0 will give you the solution for BC. And to get the value for the member force BD, you need to find out the point of intersection if it is available. Of course, it is C. So sigma MC is equal to 0 will give you the force in the member BC. So this is the approach, and if in your examination you are asked to follow the method, specifically method of section, you have to solve it in that way. If you are asked to solve the problem of truss specifically by method of joints, you have to follow the method of joints. But if nothing is mentioned, for that case, you can apply both the method conveniently. Conveniently means if we consider the free body diagram of joint B by that method of joints, so directly this SBC will be equal to P. And next thing, to get the value of these two, they must be same. So if we consider the free body diagram for joint A, from there you can solve this member which has been asked. You can solve for this member. It has not been asked, this one, but you use it for the equilibrium of joint B, and it will be automatically give you the value of the force in the member BD. So definitely you need a good practice. Otherwise, you will never build up confidence. So I expect that you go through any book and start with the solved example, understand it completely, then you attack the end of the chapter problem so that independently you can solve them. Now, next step was these three equations. I asked you to check these equations whether it has been written correctly or not, and check this value and their nature, 3p, p and root 3p with tensile, compressive, and at the end of the solution you present the answer in this tabular form. Member names.
Sir, will you please show the previous slide, sir?
This one?
No, sir, not this one. Previous one, sir.
This one?
Yes, sir, yes.
देख लिया? You take a screenshot.
Okay,
of
sir,
this.
okay.
Taken?
Yes, sir.
Now, these are the three equations, and all these three equations are moment equations. We have not used that. Now, once you find these two inclined members solved already, now we can go for this horizontal member from sigma fx0. In that sigma fx0, this p and this p are not taking any part. These are not contributing, as these are perpendicular to this direction of our requirement. Then S2 multiplied by cosine 30 degree minus S1 multiplied by cosine 30 degree, that is also negative, acting towards left. S3, that is also minus S3, that is also acting towards left. So you can form that. So idea is simple. Using it to minimize your calculation effort, to reduce the possibility of making any error or mistake, that type of thing you can acquire only through practice. And that is the investment from your part. I told you earlier also, to make any business profitable, you have to give 24 hours. Business hour is 24 hours. Office hours is not like that. Now, the present system of office hours is that in so many so-called developed countries in western part of our globe, that after office hours, if it is 9 to 5, after 5, your boss is not allowed to make any phone call to you, whatever you are doing. And at your home also, your family members will not allow you to bring the office files at your home. Okay, so you have to do accordingly. But this business, this is 24 hours job. And whatever you collect, that savings will give you that pension lifelong. Okay.
सर महीने
Yes.
में 24 आवर या फिर हफ्ते में सर एक महीने में 24 आवर देना है फिर
ठीक है, मत दो मुझे क्या?
नहीं सर मैं बोल रहा हूँ कि हफ्ते में 24 आवर या फिर महीने में 24 आवर्स वो बोल रहा हूँ सर.
देखो एक जर्मन प्रभाव है, वर्क 24 आवर ए डे, और जो काम बचे वो रात में करो. ठीक है, क्योंकि वो लोग, हम सोचते हैं कि अंग्रेजी नहीं जानते, इसलिए बोलता है कि दिन का मतलब डे, बट इन प्रॉपर इंग्लिश वर्क 24 आवर डे मीन्स इट इज दैट डे एंड नाइट. लेकिन कुछ लोग गलत से बोलते हैं वर्क 24 आवर डे और जो काम बचे वो रात में करो. ठीक है, एनीवे क्वाइट नाइस part of this type of
motivational speeches.
Motivational. फैंटास्टिक. बेटा इतना अच्छे बातें तो आप भूल जाओगे. स्कोर CA1 का जब मार्क्स मिलेगा उसके बाद हम भी देखते हैं how many people remember me as a nice person.
नहीं सर, तो ये मार्क्स की जगह है ना, आप आपकी जगह.
This thing is very important. Present the whole result in a tabular form. Okay. Now it creates that impression on that not student, whoever the candidate, the examiner will immediately find whatever the answer in short, in summary. Then your examiner will go through the steps. If at a glance here I find some mistake, instead of 3p it is twice p, and instead of this nature t it is c, compressive, then definitely you have made some mistake. So I will go for the solution for member 1. So where you get the member 1? Here. So I'll check whether these expressions you have done, you have written correctly or not. And please don't make yourself confused, and don't make your examiner also confused, because that bad impression whatever you create. Now handwriting, my handwriting is very poor, but I must be making it sure that these are legible. You can read it, MEMBER, etc. I don't ask you to write in this way. That for writing anything, you follow that drawing class procedure in this way. Draw two very thin lines. Then you write the letters required there. Of uniform height. Now, if the impression of these lines are very light, you don't need to erase them. But if you feel these lines are very prominent compared to this actual information required there, so what we do? We erase these lines and we allow this written information to be there. So properly written with equal letter height and properly aligned. But it comes, that expertise you gain from practice. So any day you start writing, maybe letters are bigger, smaller, but further bigger, smaller, and alignment is not horizontal, it is inclined. So when you finish the line, you are supposed to finish the line here, it comes like this. So please practice all these things. Naturally, nobody can help you in those things. Okay? Now, next thing, let me share another file. I'll just come out of this. Now, do you find any new page here?
Yes, sir.
Yes, sir. A
So,
new
Yes, sir.
a new diagram. Normally, it looks like a bridge, a truss, like very simple connection at their hinges. Forces applied at the end of the members only, no intermediate force. These distances, they are also same, that is geometrically it is symmetric about this line EF, but loading wise it is not symmetric. If only this 12 kilonewton force was given there, and suppose this was not there, so structurally it was symmetric, loading wise also it is symmetric. And for this case, what about the reactions at B and J?
Upward.
Vertically upwards.
Vertical upward. What about their values?
just 6 kilonewton.
6 kilonewton. Due to symmetry, it is exactly that 6 kilonewton and 6 kilonewton as the reaction at J and the reaction at A. But the given situation is not like that. It is given one more force 12 kilonewton, and due to this eccentric loading or unsymmetrical loading about this geometrical axis of symmetry line EF, here is some different value of RB and RJ. Okay. Now, from your common sense, which value should be greater, reaction at B or reaction at J?
At J.
J, sir, J.
J, because this force is more close to support J. Now, just simple mental calculation, you can find out these reactions. Both of them will be vertical upward. Now, can anybody tell me within 30 seconds?
12 multiplied by 5 by 4.
What about that simplified value?
That's 15.
15.
15,
15
sir.
at 15 at J.
Yes, sir.
And what about this at B?
9.
9.
9.
9. This is 24 minus 15, that is 9.
Yes,
You
sir.
use 1 sigma MC, one moment equilibrium equation, either sigma mj or sigma mb is equal to 0, or use 1 along with sigma fy is equal to 0. So this part is you are quite confident. So once you determine that, you indicate it 15 kilonewton and 9 kilonewton. Now, what about the members is required to find out CD and DF? CD and DF, these two. Now, by method of joints, we should start from this location B. So at location B, it will be the starting point 1. Then next joint we accept when it is known. This is also known. Joint A as second joint. Then these two are known. Then you go to this joint D at the third joint, so that you get the value of BC and CD and DF. Okay.
Sir,
So
BD is 0, sir. BD force member, sir. 0.
BD is 0. So directly by observation, it's a nice thing. So directly by observation, we get this. Now, if by any chance this member is not vertical, it is simply given in this way. Just hold a minute. We extend this member. Instead of this inclined member, this vertical member, we make it inclined and shift this hinge support.
Sir, how is BD 0?
BD 0 means you draw the earlier for the given case, BD00 means you draw the free body diagram of the joint B. Okay. So at B, here is the reaction RB. Here is the assumed tensile force in the member AB. And what about the name of this member? It is BD, so it is SBD. Now in sigma fx0, how many forces are there in x direction?
Yes, sir, understood.
Okay. So if by any chance the B is not here, it is somewhere here, and instead of the vertical member AB, it is some inclined member. So this special situation you cannot avail. So by observation, there are so many things can come up to you, and that you can develop only through practice, only through that experience. Okay. Now next thing.
Sir, is it necessary to put BD, sir? Because it is 0, na? We can remove it also. Interrupt, sir.
By observation, you can solve the problem mentally. Now simply at the end of this diagram or just beside the question, you write the answer SCD is equal to this and SDF is equal to this. And this is pakka correct answer. So just beside this question, you write these answers. What do you expect? In examination, will it be, can you demand or can you expect 100% marks? Because answer is 100% correct.
No, sir, I'm not talking, sir, about examination, sir. I'm talking about, sir, stress, sir. It can be removed also, means while making truss or not, BD force, BD member, sir.
You want to remove the member BD.
From truss, okay, sir, while making truss.
From truss. But this is engineering mechanics, not solid mechanics or strength of materials. In real structure, if we do not give any connection between B and D, then structure may collapse. Suppose here at this joint G also there is a horizontal member. It is also a null member, no force is there. Okay. Now if we remove this member, then what happens? As this roller is capable of sliding or rolling outward or inward, so ultimately you will find there is a possibility that it comes here, something like that. And if that structure is not sufficiently connected by those links which are giving the stability, the structure will collapse. As we discussed in some previous class, that 4 members are there connected at their ends with some pins, and if we have a hinge support and a roller support, we apply a force here, or we apply a force here. Then what happens? It will take a shape like this. But you cannot afford that structure to collapse. If the building in which I am residing and you have designed this building in that way, and by such applied force, it collapses over my head, definitely, anyway, that is the lighter part. So these things we need to keep in our mind.
Sir.
Because when a real structure you are considering, not this thing, this is the starting point. But when we go for designing any real structure, there you need to consider the possibility of change in length of all these members. That is, when it is under tension, there will be a tendency of increase in length, and naturally for compressive load there will be some shortening. But we are not allowing those things here. Simply we are considering as if these members are perfectly rigid, but it gives us our starting point that whenever we go for that real analysis, then at least we can start with this initial loading, what we can expect to be developed on this structure.
सर
Applied load. Yes.
मीन्स जेएच में कोई रिएक्शन फोर्स है जो उसको रोक के रखा हुआ है, नहीं तो कोलैप्स कर जाएगा, मतलब कोई रिएक्शन फोर्स है जेएच में?
जेएच में अभी तो कोई रिएक्शन फोर्स नहीं है. दिस इज प्योरली रिजिड बॉडी. नाउ आई विल गिव यू ए सिंपल एग्जांपल.
अगर रिएक्शन फोर्स नहीं तो कोलैप्स नहीं करना चाहिए था.
Here is a horizontal member. Here is a hinge support. Here is a roller support. Now what we do? We apply one lateral load there. Here. For engineering mechanics, the reaction will be, if it is P, it will be half P and half P. But truly speaking, the real analysis will not give you this approach. There will be deformation of this member. This comes in your high semester study, or if you study yourself, it will be in strength of materials or mechanics of materials or solid mechanics. Here, all these members are undeformable or perfectly rigid. So that's why it is under engineering mechanics, and this thing is not considered here. So this thing is important when we consider this. But mathematically, this member is not required when we consider that simple mathematical problem on a plane truss. Okay, but this mathematics and physics, these two are different things. To solve that physics, that is the problem of truss, we assume members are perfectly rigid. But that type of member you never get for real application. Okay, so please concentrate whatever we are doing right now, and once you build up the foundation, naturally you can build up the multi-storied building of your knowledge and wisdom regarding this subject. So now, before going to the further discussion, we finish one important job, and that easily you can understand what is that. क्या बताओ?
Attendance.
अटेंडेंस सर.
Attendance sir, attendance.
सर CA1 का मार्क्स कब मिलेगा?
मिल जाएगा. कितना चाहिए आपको?
सर 15.
फुल 15.
सर आप में से जितना आया भाई सर उतने का.
ठीक है, मैं सबको ओके, मैं सबको
आया सर उतना 13-14 भी हो जाएगी.
मैं सबको 15 में 15 दे दूंगा. हैप्पी?
यस सर, थैंक यू.
हाँ सर.
That is the most democratic.
Thank you, sir.
That is the most democratic thing in the republic country. So tomorrow we have that
Equality, sir. Equality, sir. Equality.
73rd that day.
Sir.
Okay. So to remember that, if we feel that 15 out of 15 for everybody and 100 out of 100 everybody in the subject XEC01, I think you will be most happy person in the world as a whole in the class.
Yes sir.
Yes sir, yes sir, sure
Yes,
sir.
equality.
Sir, that is the base of communism. Same for all.
एक communism क्या है बेटा?
हंस गया ये.
भाई कहाँ से ला रहे हो?
Okay, so let us go back to that. Now, after this, determination of this reaction, what we do? We consider a section which includes the members which have been asked to solve, members CD and DF. Now, if we consider any side with reference to this section, either right hand side or left hand side. Now, if we consider the right hand side, then this is the portion remaining on the right hand side. This is the developed reaction at J. These are the applied forces 12 kilonewton, 12 kilonewton at the end of the member joints E and G. And these are the forces. Here also we assume tensile forces. So force in the member AC, force in the member CD, force in the member DF, that we show as acting away from the joint as if those are tensile. Now I am not writing down that detailed equation for this equilibrium equation sigma Fy0. Sigma Fy0 क्या मिलेगा आपको?
सर SCD मिलेगा.
CD मिलेगा because directly from that equation we are eliminating DF and AC. There is no horizontal component. Only one horizontal component is there. So that's all. Next thing, we need to find out DF. So other two members should be eliminated in some clever manner. So if we can identify this point of intersection of other two forces, so directly from that equation sigma MC is equal to 0, we'll get the value of DF. Only thing you need to find out the perpendicular distance. For this case, it is given directly, most likely it is 1.8 meter. So that 1.8 meter is there. So SDF multiplied by 1.8 meter clockwise. Now we assumed this anti-clockwise as positive. So SDF will give you negative moment. This 12 kilonewton multiplied by this 2.4 positive, 12 kilonewton multiplied by 4.8 positive, and RJ multiplied by 7.2 meter. Sorry, these two are negative. These two are negative, only RJ will give you positive. So definitely this is negative. So regarding sign, you must be careful. And SDF, it is clockwise. Here also it is negative. So find out the value of SDF directly. Now, how many forces you need to consider? This one in addition to this reaction RG. Clear? So things are very simple until and unless you understand it properly.
Sir, one doubt is there.
Which doubt?
Sir, in the first slide, the 4 panel it is written dimension of that is given at the rate 2.4 into 9.6. Sir, that one. Sir, what is that dimension? Like length width?
Is the dimension is 2.4, 2.4, 2.4, 2.4. And in short, it is written at the rate.
Sir?
Yeah.
Sir, if the imaginary plane cannot cut all the required members, do we have to take one more plane?
Not necessarily one more only. It may be any number of planes when that method is specifically mentioned. Suppose you are asked to find out this CD and EF. Can a single section help you? Of course, this section can give you. But in that case, how many unknowns are coming there? Can you imagine? So maximum number of 3 unknowns you can solve from these 3 independent equations of equilibrium. Sigma fx0, sigma fy0, or any independent sigma m0, or any independent sigma m0 when 3 points are non-collinear. So when you are asked to find out the force in this member and in this member, then you select this one, section 1.1, and you can select this also. Two, because in that 2, this is already known from section 1.1, and here it is left only with this unknown force and this unknown force, and you can find it. But if no method has been specifically mentioned, then the clever students will select this method of joints at point E. At E, this is the 12 kilonewton applied force. Here it is SEF, here it is SEG, and here it is SCE. So you don't need to bother about multiple number of sections in that way, but you are in trouble if specifically it is mentioned that you have to follow method of sections only. Otherwise, you solve for this by method of section, you solve for this member by method of joints, because SEF minus 12, that is equal to 0 in kilonewton. So SEF is minus 12 kilonewton, that is compressive. Okay. So better, there is no such a hard and fast guideline how you need to solve it. Anything, any method. In fact, in perfect geometrical way also you can solve it. That is the pure graphical method. For simple joints, etc., where 3 forces are there, one in the form of reaction or applied force, other 2 are unknown member forces. You can draw that vector polygon in the form of a triangle. Okay, but in this 45 minutes class, it is really difficult for anybody to give you everything, all knowledge about this thing. You have to go through the things individually and independently. Now, next thing, if we consider this thing, the portion of the structure on the left of that section, here also those same forces are there, member AC, CD and DF with same nature assumed, tensile, tensile and tensile. But how many forces are there? Only one developed reaction, RB, and that is equal to 9 kilonewton. So in that equations of equilibrium, there is no such business of additional 12 kilonewton, 12 kilonewton, only one reaction. So your equation becomes simpler. So बेटा चालाक बना, काबिल बना, to minimize your effort, और clever लोग हमेशा अपना क्या
दिमाग चलाते हैं.
हाँ. So do not give unnecessary time, but your answer must be to the point, answer to be written very systematically, diagrams must be very neat and clean. So all such things are there. Now freehand drawing may not be, you may not be very much, rather what I should say, expert about that. Not all people have that ability, very nice things to bring out of your hands. But practice, yeah, makes
A man perfect.
Man perfect.
everybody perfect. Now sigma fy0 will automatically give you the SCD. Now what about the nature of this force SCD? RB plus SCD. Anyway, let me write here. RB plus SCD is equal to 0. So SCD is equal to minus RB, that is minus 9 kilonewton compressive. Okay. Next thing, sigma MC is equal to 0. And you can find out the value of SAC also from sigma fx0. From sigma fx0, SDF plus SAC, that is equal to 0 because other two forces are vertical. So SAC and SDF will be of equal magnitude but opposite in sign. Okay. So please try this thing with this given information and solve for these members, and you please take up so many problems. Things are very simple and interesting. Okay. So please do these things. In fact, even if in any book you find two separate chapters or sub-chapters provided, one for method of joints, other for method of sections, you can do one thing. You can solve those sub-chapter for method of joints by method of sections also, and you can solve the assigned problem on method of section solved by method of joints also. And you can combine if there is no.
Sir, in the examination, it will be mentioned that solved by method of joints or method of sections.
Normally not, because in examination normally we try to minimize the trouble of average of the class for the middle batch. But if you consider the normal distribution, that peak of that parabolic distribution, there are very few people are there. So if your examiner or your paper setter sets the question in such a way, only those people can answer. That 10 or 15% cream. Okay, then what about the others? We teachers are here to teach you first, then to test you, to get the feedback of your knowledge, how much you know. It is never our intention that how much you do not know. And that should not be the system of any education. Education is a continuous process. Today I am a teacher due to my teacher's contribution for making me teacher. And I will be happiest person in the world if any of these 184 students in section H and I become a successful teacher. That will be, you can definitely understand. And one thing, even right at this moment also I can say that there are so many poor students in this class who had to give private tuition for some junior students in your school or in your locality. Is there anybody provided tuition, taking money or without taking money?
Yes, sir.
Corona time, sir. Corona time, no tuition.
बेटा कोरोना तो तेरा स्टैंडर्ड 11 स्टैंडर्ड 12 में आया था ना, उसके पहले.
Now only, sir. Now only. That's why we are not coming to NIT now.
बेटा स्कूल में कभी किसी को पढ़ाया नहीं, जूनियर बच्चों को?
Yes, sir. आपका
क्लासमेट
स्कूल में तो पढ़ाया है सर.
क्लासमेट को ही सर.
बेटा बहुत सारे लोग कभी-कभी. हाँ.
जूनियर्स को
पढ़ाना पड़ता है.
टीचर एब्सेंट होता है.
तो कभी-कभी पढ़ाया. तो आज के लिए इतना ही काफी है. So you collect your whatever queries you have, you jot it down on a plain piece of paper, and in our next class you share it. And for tomorrow, normally we celebrate the Republic Day with flag hoisting and the speech of our director. Most likely you will experience it through your website. I think it will be there in our institute YouTube or Facebook, or directly from the website also, that link will be there. I don't know exactly. So if it is given, please participate there वर्चुअली। ओके देन, तब तक के लिए आज्ञा दीजिए। प्लीज परमिट मी टू या।
थैंक यू सर।
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
मोस्ट वेलकम, मोस्ट
Thank you,
वेलकम।
sir.
Sir, Republic Day के लिए give thank you, sir. 15 marks.
ओके,
अब कौन सा क्लास है भाई?
बायो बायो आ जाओ।
बायो।
अपना लाइफ
तो भाई
साइंस
थैंक यू कौन बोला
गूगल
सर को?
मीट का लिंक है वहाँ पे जाओ।
Google Meet में होगा।
थैंक यू कौन बोला सर को? अभी 15 मार्क्स मिले नहीं है, मिलने तो फिर बोलना।
भाई रिकॉर्ड हो रहा है।
कुछ नहीं रिकॉर्ड होगा, छोड़ो।